Dr. Clement. He's also from Auburn University. And he's going to be talking about some of the fingerprinting, like we started talking about in the question and answer period before lunch, and also some of the toxic chemicals that are found in some of this oil. So take it away.
All right, thank you.
You're welcome.
Well, thanks for coming. So I thought I would probably start with this picture. So this is what I'm going to present is a joint teamwork working with a lot of people. Except I work with Dr. Hayward, so when we get the funding, he gets the cool boat to go after tar mats, I get a dead crab net. I thought it's kind of unfair. Don't you think so? Well, that's my life, okay? So it is hard, sweat, and blood, like over 30 to 40 sampling events, just walking these beaches. I got all kinds of interesting stories to share. Some old ladies would walk in and say, "Oh, you're doing a good job, honey. Have some Coke." So I drank some Coke. And I had incidences where cops would come and say, "We're going to arrest you, man." And with this accent, I mean, I'm growing beard now. Thankfully, I didn't have. I would have been in Guantanamo Bay, okay? And thankfully, I'm not. I'm still here, okay? So if you ever saw the news clip, please support me. Take me out of Guantanamo Bay, okay? Thank you. Okay, so what do I do? So what I do is, as I said, for the past 5 years, I've been just collecting tar balls. I got about lots and lots of, like Trump says, I am really rich in tar balls. Lots and lots of tar balls, okay? Close to 10,000 tar balls in my lab, okay? So that's kind of my area. I kind of evolved into this area. So what I'm going to do is, since this is a science communication type seminar, I'm going to try and summarize 5 papers we recently published, okay? And you can come to the website. That's my email address. You can take my email address. You can get all these papers or come to my website. You can download them. And you would also see that in Gomri and other places, okay? So now when you do research, somebody has to pay for it. Well, somebody has to work on it, which is graduate student in my case. And so they get to do the work. I get to go around and talking about it and gabbing about it. And some of my graduate students are here, postdocs and colleagues, Dr. Hayworth and others, and ADM. We worked with the ADM folks for sampling and other events, and somebody has to pay for it. NSF was the first one to pay for it, some of the equipment, MISEC. Now, one notable funding agency missing is Gomri, okay? Yes. So we not got a penny from Gomri, although all our publications are posted in Gomri. So when Gomri says the money generated this much research, it's not a necessary condition, okay? They list other papers too. But it's been a fun work. So my presentation, I'm going to turn it around. Typical science presentation, you make a presentation and do a conclusion, right? I'm going to give you the conclusion. I'm going to let the cat out, okay? So this is my conclusion. The key conclusions of all those papers we have published so far is, I'm going to make a case, current oil contamination levels, we call tar ball. It's a very bad name, and Supi talked about it, others have talked about it. It is not tar ball, and I will make a case for it too. The current contamination levels are well above the pre-oil spill condition, okay? The current tar ball activity or oil contamination levels. The second conclusion is somebody talked about fingerprinting them, identifying them. If you ever found a sticky, fragile, brownish, sandy tar ball along Alabama coastline, I don't know about other coast, okay? Because I primarily worked on the Alabama coastline. They are from BP oil spill, and I'm going to make a case for that, okay? Third, people talked about toxicity effects. Well, I'm going to make a case that there are indeed some toxic chemicals, specifically PAHs, polycyclic aromatic hydrocarbons. They're pretty nasty stuff, and they are still trapped into some of these residues, and unfortunately, some of them are not degrading. And why, we really don't know, actually, okay? Now, what are the implications, what are the risks, and that's a completely different ballgame. So these are the, hopefully by the end of it, you will know why I made these conclusions, okay? Okay, so let me start with this. This is 2010 May, this oil spill happened. So here's a kind of an aerial extent of this floating oil, actually. This was a floating oil at the time, okay? Now, when this happened, I'm actually a groundwater hydrologist who looked at contamination of groundwater, both oil and other contamination. So when this happened, the problem with the groundwater is you don't see a contamination. We do all kinds of work, but we can't see groundwater, right? It's buried. We only have a small well to dig. So when this happened, it kind of excited because now I can see a contamination, right? So I rushed to the Gulf, and basically we focused, our study region is primarily Alabama coastline. So we went there, that's what I saw. Okay, you saw all these beaching of the moosey oil everywhere. And at that time I had no clue what I'm doing. So I said, I don't know, but I'm going to collect some. Why? I had no idea why, okay? Now, this turned out to be one of the best decisions I ever made in my life. Because those are reference samples collected by me in my lab. We still have it. This was collected on June 13th from Alabama shoreline. These are the original moose we have, because now it's very easy for us to identify. Nobody can contest. We have the moose. We actually have the moose. Okay? So that's our reference sample. That's when the whole thing started. June 13th, when I started sampling this thing, and we put it away there, basically stored it. Okay? Fast forward, what we realized very quickly is within 4 or 5 months, some oil sank. Okay? The question is, what I was scratching is, well, when I was on the shoreline, the oil was floating. What happened? Why did it sink? That was not easy. Now we know that. But the science evolves with time. Sometimes things are not obvious. Okay? Now with time we realized the reason oil sank along the shoreline is it basically interacted with the sand. The sand got suspended when the waves started breaking, and then that sand interacted with the floating moose, and then it sank, because oil generally floats, right? So we are talking about this very localized sinking process. Some oil also sank very close to the wellhead because they interacted with the drilling mud. That's not what we are talking about. We are talking about sinking very close to the coastline. Okay, so it sank. So the result of sinking was it started forming what we call submerged oil mats and submerged residual oil balls. I hate to use the word tar ball because they are not tar balls. Okay, although from a general communication with the public as well as the journalists, I have to use the term. So it is okay to use, as Steve pointed out, but keep in mind they are not tar balls. Okay, so what you really see is a bunch of tar mats sunken. We've seen it in Alabama, and then they break apart. When it's big enough, we call some basically submerged oil mat, and then they get shaped, and we call SRBs or tar balls, if you will. Okay. Now, as Dr. Hayward is kind of going after this problem, which is a lot more difficult problem. It's also a cool problem. He gets a boat and get to do fishing and all that. He doesn't tell me that. Okay, so there's a lot of research going on in our lab going after this problem. But we primarily, our subgroup kind of focuses on this thing. So what do? We just walk the beaches, basically. Many times. I mean, I've done at least 20 field surveys. We just go there after every storm event. We kind of go in disguise when they do some cleanup and then get samples. So what we did was every 2 to 3 months we go there and do a very systematic sampling, and we archive the data, basically. And we also keep all these all these samples in a storage. So we got a whole history of reference samples in my lab. So here are some of the latest surveys. February 2013, just before they start the shoreline cleanup activities. That's BP folks actually walking with crab nets. They got big money, so they have a big crab net. So I have small money, I can use a small crab net. Okay, so so they do that. So we kind of go behind them before. So we kind of before they could walk, we kind of go ahead and try to pick as much as we can actually. So see, here's what we picked in February 2013, August 2014. So this is our field sampling. So you might ask the question, so what? What's happening now? What's going on? Well, here's the latest survey we did. This was actually done with ADM. Roy is still right here. So we walked with him, a couple of my graduate students, myself. We pretty much surveyed the entire Alabama coastline, all the way from Fort Morgan trip to Orange Beach. For some reason, when we reach the Alabama border, we stop. Okay, that's our limit. Actually, we had enough with the crab net walking. Okay, so these are our control points, really, if you will. So this is like 2 months back. I'm giving you one sample. This is Bon Sequoia. You can see that's the actual close-up of the sample. Okay, so there is plenty of oil there. Okay, still there. Okay, now if you do not have an eye for it, if you go there, you can't find one. Okay, so what I did was yesterday I just walked here, right? What is that? Fort Detrick coastline, right? I found a couple very quickly. Sea was really rough, and we could not find anything. And I found a couple. I brought it for a reason, and I'm going to pass it around. Okay, so it's there everywhere. Okay, and you need to have an eye for it. Well, then comes the question. Well, there are tar balls. We admit this is a classic journalist question, right? They cannot say SRB. I don't know why. We have tar balls. So what? Gulf of Mexico always had tar balls. They always had contamination. So what? Well, first of all, my contention is this perception is not true, at least for Alabama's beaches. I've also sampled in Texas, okay, Houston, around Houston. It's slightly different. Now, how do I support it? Well, in early May 2010, before the oil arrived, I personally sampled the entire Alabama coastline. Okay, I could not find anything. Not even other tar balls. As occasionally we do find other tar balls. I could not find anything. Now, if you don't believe me, you can believe the SCAT team. SCAT did the survey, very similar time, and their report summarized in Orange Beach, at least in Orange Beach, they found no tar ball. That's the baseline they report. Okay. Now, other places they did find some tar balls. How many they found? They found 680 tar balls of non-MC252 tar balls, which is basically 680 tar balls which are not of BP oil spill signature, and which was recovered from Louisiana, Mississippi, Alabama over 900 kilometers. Okay, so if you surveyed 900 kilometers, you could collect about 600 tar balls, which took about 4 to 5 months. So based on not our data, based on the published government data, SCAT data, Unified Command data, we actually did a summary and published a paper that said roughly pre-oil spill background level, based our hypothesis is about 1 or 2 centimeter sized tar balls over 5 to 6 months. Okay, that's our hypothesis. Nobody has invalidated. Please feel free to. Okay, and we have the data, and we did our best. Okay. And as for, this is for Alabama's beaches, by the way. Okay, so that's the background. Okay, so the perception that there are tar balls everywhere in Alabama, not really true. There are there, but not much actually. So then the question came when they started to stop the cleanup condition. What did they do? The federal guidelines said remaining tar balls and tar patties should be at or below the background frequency. But they never defined the background frequency until we published a paper. Our paper was the first one to estimate the pre-oil spill background frequency, or a hypothesis for the pre-oil spill background frequency. Okay. Now, so the question still remained: what is the current status? Are they below the background level? Okay. And the report itself never talked about the background level in detail, actually, except there are a few mentioning of few points here and there. Okay. So here's my evidence for you. This is really fresh, last week. Okay, I did a sampling survey in Lagoon Pass because that's our control area. We go quite often. This is 19th. No, it's not. I lied. It's 2 weeks back. Okay, July 19th, 2015. It's a Sunday. I recovered about 50 tar balls, size ranging from 1 to 10 centimeter. You can see that. That's the scale. Just near the Lagoon Pass alone. This is 2 weeks before. Okay, it's right in my lab. Okay, and it's a NRC sample. We called NRC, reported it to them. So it's official, actually. Okay, so this is obviously nowhere close to the background I talked about, which is 1 or 2 tar balls every 6 months. And it's so my very first assertion. Remember, my first conclusion is in Alabama, we are nowhere close to the background. Okay, that is true. Here's one of the conclusive evidence. We got multiple sampling data sets. Okay, now moving along, we should say, well, how do you know they are DWH tar balls? There are seeps everywhere. People spill things all the time. How do you know? Are you smart enough to know? Well, I'll tell you why I know they are DWH tar balls. I'm going to make a case for it. Okay, so in order to do that, I actually put a non-MC252 tar ball right here. They are typically blackish, rubbery tar balls. Okay, more than anything, they float. Okay, why they float? Because if they didn't float, they would not come to the beach in the first place. So wherever they form, we really don't know. Science is kind of open on that, but they float. So we can find the density of it. It will be less than 1 for sure. Otherwise a Nobel Prize winning invention, okay? Something is floating less greater than density 1, forget about it. I'm now in the Einstein level, right? So I don't have to worry about tarball research anymore. So trust me, it floats, okay? So it's pretty simple actually. Find the density. Take the tarball, put it in the beaker of water, take some McDonald's cup, drink the Coke, get some seawater, put the tarball in, it sinks. Highly likely it's DWH tarball. Number 1. Number 2, you break them apart. You just take it, squish it. It's nasty and it sticks. You don't believe it? Here are a couple of tarballs I collected yesterday. They're pretty small. You are welcome to break it because I'm not going to take it. I got plenty of these stuff. And you can smell it. It'll smell like a fresh tarball, actually. And if you want to venture into it, put your hand and try to squish it. It'll stick. The third one is you'll find a lot of sand there. Sand content is almost 80%. I'm going to just send it around. So you feel free to play with it, actually. Okay? So if they're brownish, sticky, lots of sand, petroleum smelling, they are DWH tarballs. Okay? That's it. There is nothing else is needed. I'm going to support it. Why? Okay? Why? I'm going to go further. If you're a common person, like a public, we want to involve public in some of this sampling down the line, that's the only test needed. That's the only test needed in Alabama. Again, I'm not talking about other beaches, because I don't know all other events, okay? If they are sticky, brownish, fragile, petroleum-smelling tar balls, and if you can break them apart and the density is more than 1, they are DWH tar balls. Okay, why? I have a $1 million equipment to prove it. Okay? So if somebody challenged you, saying that, hey, I found a brownish, sticky smelling tar ball which is sinking, and somebody said, no, it is not DWH tar ball, email me. Send me the sample. I'll be there. Because I'm yet to find one. I openly challenged in several discussions, okay, show me a tar ball, recovered from Alabama, sticky, brownish, petroleum smelling, with lots of sand content, and this is not a DWH tar ball. That's a science paper. Science is kind of the top journal for us, okay? And you ain't doing that because I'm going to analyze and show it is indeed DWH tar ball. So how do you do that? Well, the way in which we do fingerprinting is when the petroleum is formed. Petroleum takes millions of years to form, okay? And petroleum forms from animal death or plants, basically. When they get buried, they form, right? And they leave behind a biomarker, just like a crime scene, okay? So these are very specific biomarkers, hopanes, steranes, diammonites. There are a whole bunch of biomarkers. And the petroleum chemists have been studying this for years, not years, decades actually. Okay, so what I had was, I was luckily came across a book written on biomarker, a fellow working in Stanford, and one of the fun part was to interact with them, okay? So they have these biomarkers, so we have those biomarker samples. So we can actually use, this is the equipment I said NSF paid me to buy. We can use some sophisticated instrument and we can get the fingerprint, just like a crime scene, okay? So we can get the fingerprint, and there are several ways to play with this fingerprint. A simple way to do it is you take a hopane data and look at 2 specific hopane, TSTM and C19 and C29, and you'll have a flat and an ascending pattern. And if you take another oil like Arabian crude, Basra crude, Venezuelan crude, they'll have different, flat and a descending, ascending, descending, ascending, ascending. So there are some very simple ways. This is a very simple way to this thing. So you take the DWH tar balls, they all have the flat and ascending pattern. Okay. This is, by the way, this is a very preliminary. Now you can also go after various other compounds there. I just want to give an example, given the time constraint. Okay. The second level, we can dig into the numbers. We can find the DWH tar balls have a very unique signature of 0.91 for this ratio, this specific ratio, for example. And for this ratio, it's got 0.38. Other oils do not. Okay? And then you do all the tar balls and stuff. Here it is. The ratio comes out. Okay? So this is second level. This is very primitive still. We can dig into several things. There is styrene, there is hopane, there is diammonites. So there are several levels we can dig in, look at ratios and fingerprints where we can actually show it they are indeed from DWH, Deepwater Horizon spill. The last thing we do is we look at PAHs. What are PAHs? They are polycyclic aromatic hydrocarbons. They are toxic. They are known toxic compounds. So they do leave a very specific fingerprint. Here's the DWH residue characterizing all the pHs. And here's Galveston Bay oil spill residue. So I was there. I was in Houston when the thing happened. I went there and sampled. We came back and characterized. You can see a completely different, we call it mountain plots. Each one form a mountain, and the mountain will be different actually. Okay? And then DWH has got a very specific type of mountain pattern. Okay? So my second question, all sticky, brownish, petroleum spilling tar balls are indeed from DWH oil. That's my second conclusion, grand conclusion. The last one is, why do we care? Are they toxic? Well, that's a separate topic. I could spend hours on that. Well, here's one data. Dr. Hayward talked about it a little bit. We specifically look at a toxic chemical called PAHs, polycyclic aromatic hydrocarbons. And some of them are toxic, some of them are really, really toxic. One of them is really nasty one is called chrysene. It's a known carcinogen. Okay? So we track them. It's a marker. Okay? Now, that particular marker, it turns out, for various reasons, and we are still playing with the science, when the oil was actually released at the wellhead, there is no depletion. Of course, it's a fresh oil, right? And then there was a lot of evaporation. There is not much depletion. But when the oil was floating, there was a lot of depletion in chrysene. We suspect it's due to photodegradation. It's roughly about 40%. But once the oil is buried, there is absolutely nothing. It's almost flat. Okay? So some of these compounds, now, it's not that it's going to kill you immediately. Okay? But to me, it's like putting a couple of tablespoons of cyanide in your swimming pool. It's not kill you. Would you like to swim? I don't know. I won't. Okay? So we are leaving something behind. Okay? It's a policy question now. Okay? So there are chemicals. As a scientist, all I can say is, give me that sample. I can show you there is chrysene there, and it's not going away. What should we do about it? I don't know. I still want to drive my SUV, which means I want petrol, gasoline. So I'm part of the problem here, right? So it's a policy question. I'll leave it to the politicians and smarter people. So all I can make is this very simple, simplistic conclusion, which is the current level of contamination levels or tarball activity levels are well above the background. And we have done it, we will do it. We'll continue to monitor. And sticky, fragile, brownish tar balls, all you need is a physical fingerprinting. You don't need chemical fingerprinting. We know for sure they are from DWH oil. If you found along the Alabama, Florida coastline. And there are some chemicals are left behind in these tar balls, of which we really don't know. The risk is really not known. All we can say is these chemicals are still there. Okay? So with that, if I were the king, which I'm not, I would like to see somebody tracking these chemicals, at least what's going on. I mean, know the biology. The next talk is going to talk about it. Eventually, biology is the king. It's going to take over and kill these chemicals. It'll be nice to know that, actually. Okay? Nice to know the fate of it. And also, let's try to figure out what's going on. Let's have some sort of a long-term monitoring. Okay? So with that, I'll stop, and maybe we can discuss this later. Thank you.